Okay, the next lab for you guys is an esterification reaction, which is what we'll learn more about in chapter 21. But um, right now we have gone over alcohols, and we do know that alcohols do have a tendency to react with, for instance, I showed you in class sulfonyl chloride. In this case we have an acid chloride, we have specifically acetyl chloride. So again, couple things, you are going to run this reaction in the hood because HCl is your byproduct, and that means that you guys are going to work in groups of 3. Alright, let's take a look how the reaction proceeds. So hopefully you can see and envision that it's the alcohol, which is your nucleophile here, and it's going to attack the electrophilic carbon over here, which is the acid chloride, and force the electrons to go on top of oxygen. That's going to give rise to oxygen with a negative charge. You have a Cl, you have an OH, and then we are going to get your propyl chain. Since oxygen is forming 3 bonds, you must give it a positive charge. As the negative charge comes back, Cl is going to leave. You're going to end up with a protonated ester first, and then that Cl would want to remove that proton off. That's how you get your HCl, and you end up with the ester. Now, the way the reaction is run is what you're going to follow from the handout, not from the book. So please make sure that the procedure is reflective of that. Alright, so what you'll do is you will begin with the large 6-inch test tube, and you're going to place 4 milliliters of propanol in that. So let's take a look what that setup is going to look like. So you'll maintain an ice bath. Let's say that's a 400 milliliter beaker, and you put ice, let's call it wet ice, and you're going to clamp the large test tube. You're going to put a stir bar inside because you don't want to continuously use a glass rod and keep stirring, but rather have the reaction stir itself. You're going to put, like I said, we have 4 milliliters of propanol. So that's my nucleophile already in place. We are cooling it because as we go through the reaction, this is a exothermic reaction. So if you don't cool the reaction in the beginning, the reaction can get heated up quite a bit, and the boiling point of your acetyl chloride, that's only like 52, I think 51 or 52 degrees Celsius. And so what's going to happen is you're going to lose a lot of material because the reaction generated a lot of heat, and so you're going to lose a lot of reactant. If the reactant is not there, obviously the reaction is not going to go through, and you will still see the alcoholic peak at the end of the day. So that is the reason why we want to cool it for about 10 minutes. Now, as you cool it for 10 minutes, you will then slowly add 4.5 milliliters of acetyl chloride, and you will make sure that the temperature never goes beyond 20 degrees Celsius. What does that mean? You're not supposed to eyeball that, oh yeah, probably I did not allow it to go since the ice bath was there. Make sure that you do insert a thermometer and clamp that, and make sure that you are really rigorous about the fact that the temperature doesn't go past like 20. This has to be a slow addition. You will see that as the reaction goes through, it will seem to bubble a lot. It will get hot, and so again, make sure that the temperature is cold. Now, as the addition is complete, you will then remove the ice bath first and stir it at room temperature. So we stir it at room temperature for 15 minutes. So that means now no ice bath. And at that point of time, you probably should get a smell of with a fruity flavor, and realize that all esters, they do have a fruity smell associated with it. Rose, for example, or bananas, pineapples, they do, all of them, they do have a fruity smell. Isobutyl is in case of bananas. Rose has 7 carbons with a benzyl, actually. So as you get that smell, that's a good sign, because that tells you that the ester is being generated. And after the 15-minute period, once that's over, what you're going to do then is quench the reaction. So you will take another 250 milliliter beaker, and you're going to put in that ice cold, saturated sodium carbonate. I know the instruction probably says 20 milliliters, but we are going to go with 25. Okay, and as you take that, I want you to add your reaction mixture. So make that correction. We are taking 25 milliliters, and we are going to add the reaction mixture into your sodium carbonate. You will see that as you do that, perhaps because of the excessive HCl that got generated, you might see bubbling in this solution, and that's obviously true. Recall from Gen Chem 1, HCl is going to react with sodium carbonate to release CO2 gas, so of course you're going to see bubbling. Now at that point of time, I want you to check that the reaction mix is alkaline on the pH paper. That means what you need to do is take a glass rod, swirl it well first off, take a glass rod, dip it in the aqueous layer, and put it on the pH paper, and the color should be kind of like a key lime green. If you see a key lime green, that's good. If not, then you have to add a little bit more sodium bicarbonate, or sodium carbonate rather. And then what you're going to do is you're going to place this entire mixture in a graduated cylinder. So try to go slow, because you don't want to overfill the graduated cylinder. So I want you to transfer this into a 25 milliliter graduated cylinder, or a 50 milliliter graduated cylinder, whichever is available. You can begin with, actually, since I increased the volume, you can begin with the 50 milliliter graduated cylinder, and you will see the 25 milliliter mark will be the aqueous layer, and then a couple milliliters on top of it would be your organic layer. And at that point of time, you wanna transfer all the organic layer into a separate Erlenmeyer flask, and realize that it's a possibility that because the 50 milliliter has a wider mouth, you might have a little bit which will stay pretty close to the layer, and at that point of time you can transfer this into a second round 25 milliliter flask. And so since that is narrower, you will see this really flattened layer kind of deepen up a little bit, so you can get till the last drop of the product, you can actually collect that. Anyway, so collect that and place it in a beaker or a smaller test tube, whichever is available. You will then add the desiccant. The desiccant is basically to remove any moisture, because we had added an aqueous solution of sodium carbonate, and just swirl it gently and allow it to sit at room temperature for 10 minutes. At this point of time, you should see clarification, like your murky, turbid, cloudy solution should kind of clear up a little bit. And then you should also see that the magnesium sulfate that you had put in, or the desiccant that you had put in, that stays at the bottom, but a little bit of it moves as you gently swirl. And so at that point of time, you will be ready to transfer it into a pre-weighed flask or a beaker. So pre-weigh your flask, transfer it into that, and get your IR, get your mass for the percent yield, get your eta. Your eta is going to be really significant because the eta of the starting material, which is the alcohol, and the ester are really close. And so your final two digits are going to tell me how good you are with the eta. That will be it. So what are we reporting? We are reporting several things. Your observation table, you should at this point of time be well versed with how to set up your observation table. Several of you are doing it, several of you are not, and obviously your grade is going to be reflective of that. So again, one more time, I'm going to do what needs to be done. Mass of empty flask. Not weight, mass. Mass of flask plus product. I need to see all of that. Mass of product alone. And so this is your result essentially that you're getting. You will then calculate the percent yield. So calculate your TY, how much, show me the work for that. Calculate your percent yield. And you will take the IR, and then in your conclusion section, you're going to discuss how well the reaction worked. That means you will discuss your percent yield. You will discuss the IR, which peaks are present and absent, present or absent. And you will discuss the eta of your starting material as well as your product. What else? You're also going to give me what your sources of error were. Sources of error. And that will be it. That will be a lab. It's a pretty straightforward, sweet and simple lab, but just depends on how well you get your data together. All right, I'll see you in class.